Today we're showcasing a new class of mechanically robust, ultra-strong aerogels called Aerogels. On the left, we have here a 1-inch disc of classic silica aerogel. Now this is the holographic blue-looking super insulating material of NASA lore. And on the right, we have a similarly sized 1-inch disc of a new material called Aeroloy X100. Now, when I weigh the silica aerogel disc, you'll see that its mass is about half a gram, which means that its density works out to be about 100 milligrams per cubic centimeter. And when I weigh the Aeroloy, we see that its mass is also about half a gram, which means that it has the same density as the aerogel, about 100 milligrams per cubic centimeter. Now, despite the fact that aerogels are supposedly super strong materials that can hold thousands of times their weight in applied force, anybody who's ever handled an aerogel will attest to the fact that they're actually very brittle. And so, as you can see here, with very little force applied from my hand, I can break the aerogel into shards just from pinching or poking it. Now the Aeroloy, on the other hand, is not brittle. It's actually very strong, and I can pinch it and poke it all I want, and it will stay relatively intact. In fact, I can even bang it on the table and bang it with my fist, and there is no visible damage to the disc. And in fact, not only can I do this, I can actually whack the disc as hard as I can with a hammer, and the material will only deform plastically. It doesn't break into shards like a typical classic silica aerogel. Now, these enhanced mechanical properties mean that Aeroloys can be machined like any ordinary engineering material, unlike classic silica aerogels. And so here I'll demonstrate taking the Aeroloy disc and a drill, and you can see it's as easy to drill as any other engineering material, such as wood. Now, aerogels don't stand up to water very well, and so here we have a beaker full of water, and you can see when I place the shards of aerogel in the water that they shrivel up, they absorb the moisture, and they turn white. And as a result, this limits the practicality of silica aerogels and other classic aerogel materials for many applications. Now, Aeroloys, on the other hand, are impervious to water and will float on water without damage. And so you can see here the Aeroloy disc floating on water, and it will remain to do so for a long time. Now lastly, Aeroloys, like their cousin aerogels, are super insulating materials, so that means that they have the great low thermal conductivity that we expect from nanoporous materials like aerogels. So this means that Aeroloys are the world's first structural super insulation, materials that can double as both structures and insulators. Sample-sized pieces of Aeroloys are available online at buyaerogel.com.